Welcome back to the deep dive. Our mission here, as always, is pretty simple. We want to give you the ultimate shortcut to being well-informed. We make sure you get the most crucial knowledge from all the latest analysis, and you get it fast, but you also get it with total thoroughness. Today, we are diving deep into a sector that, well, you might think of it as traditional, but it's actually going through one of the most profound transformations in the entire global economy. We're talking about manufacturing. So, forget that old image of dusty factories. We're looking at the absolute cutting edge. Our mission today is to figure out exactly how artificial intelligence is moving beyond just a simple automation, a robot arm doing one task over and over. We're exploring how it's becoming the strategic engine, the actual core decision-making driver that is just completely revolutionizing how things get made. This isn't just a small step forward, it's a total pivot.
Okay, and I think we need to unpack that right away. Because to really get why AI is a strategic engine, you first have to understand just the extreme pressure that manufacturers are under right now. This isn't just a nice to have. It's not just about, finding a few efficiency gains. For a lot of these companies, it's about survival. The source material we've been looking at, it highlights what it calls a strategic manufacturing squeeze. And it's defined by these twin challenges that are hitting them from both sides. They're eroding profits and operational capacity all at once.
The twin challenges. Okay, that sounds pretty intense. What exactly are these forces? And are we talking about a local thing, or is this a global phenomenon?
Oh, it's absolutely global, and it's systemic. The first challenge is the relentless rise in input costs. And it's not just, a little bit of inflation. We're talking about massive volatility, the cost of everything you need to actually make something.
So raw materials, energy.
Exactly. Energy prices can spike because of some geopolitical event halfway across the world. Raw material markets for, say, specialized metals or polymers can jump 30% in a single quarter. So just imagine trying to run a business, trying to plan for the next year when you have no idea what your core components are going to cost in 3 months.
That kind of volatility it crushes your margins. You can't price your products accurately. You can't make smart long-term investment decisions.
You can't. It's paralyzing. And then, layered right on top of that financial pressure, you have the second challenge, which is just as severe: deep and persistent labor shortages. And this is really complex. It's not just a shortage of entry-level workers. In many cases, it's a critical shortage of the really skilled people.
Specialists.
The specialists, the technicians, the engineers, the maintenance crews who have, 20 years of institutional knowledge about this one really complex machine. These are the people you absolutely need to keep a modern factory running. And when you lose that experience, you don't just lose a pair of hands, you lose what people call tribal knowledge.
Right.
It's irreplaceable in the short term. So that operational need to fill those skill gaps is a huge driver for intelligent systems.
Okay, so you've got higher costs on one side and fewer skilled people to manage those costs on the other.
Right, it's a pincer movement.
And as if that wasn't enough, the outline points to a third layer of pressure, which feels like the real complexity multiplier here.
The consumer demand.
The demand for hyper-customization.
Absolutely. The market it has completely moved past the one-size-fits-all era. You, me, everyone. We expect personalized, tailored solutions. But we want them at the speed and, frankly, the price of mass-produced goods.
And that's the strategic knot, isn't it? How do you possibly deal with rising costs and a shrinking skilled workforce while at the same time massively increasing the complexity of what you're trying to produce?
Exactly. Traditionally, if you wanted high customization, that meant a slow, expensive, bespoke production run. The old way of doing things forces you to choose. You can have efficiency or you can have complexity. Not both.
So this is where AI comes in.
This is where AI becomes, as the source material puts it, a vital component. It's not just a solution. It might be the only solution because it's the only system we know of that can handle all of those conflicting demands at the same time. Cost reduction, labor augmentation, and complexity management. It meets market complexity with technological sophistication.
That sets the stage perfectly. Let's move into our first section then and really dig into the operational core of this. Before we get to the big picture strategy, you have to ground this in results. I mean, you've got to show how this translates into immediate measurable savings.
Of course. Implementation costs a fortune, so you have to have a rock-solid business case.
And that's why we lead with efficiency and precision. Because the core promise here is something that has, historically been almost impossible to achieve.
Which is cutting your operational costs while at the same time enhancing your product quality.
Right. You used to have to trade one for the other. Better quality meant more inspections, slower lines, higher
Yeah.
cost. AI seems to promise that you can just erase that trade-off.
It does. And a great place to start is with probably the most dramatic example of that, which is using AI to predict equipment needs.
We hear the term predictive maintenance thrown around a lot, but for someone listening trying to understand the strategic importance, what does that actually mean? How deep does this prediction go?
This is a fundamental game-changing shift in thinking. We're moving away from two models that are just incredibly inefficient. The first is reactive maintenance.
Which is wait for it to break.
Wait for the catastrophic failure, exactly. And the other is scheduled maintenance, where you replace an expensive part every 6 months, whether it needs it or not.
Both seem incredibly wasteful.
They are. Reactive maintenance leads to what the industry calls costly unplanned downtime. If one critical machine in a huge integrated facility goes down, the entire line can grind to a halt.
And that's not cheap.
You're talking tens, sometimes hundreds of thousands of dollars per hour. Not to mention the cost of rush shipping a new part and paying overtime for emergency repair.
And the scheduled maintenance.
Safer, but you're throwing away a perfectly good asset. That part might have had another year of life in it, so you're just burning through capital.
So AI gets rid of both of those problems, the waste and the risk at the same time.
But how? I mean, how can it be that reliable? It's not just a timer, right?
Oh, it's so much more than a timer. We are really talking about a world where the production line itself anticipates its own maintenance needs. Sometimes weeks or even months before an issue would actually become critical.
How does it do that? What's it looking at?
It's all about data. Massive, real-time data from all kinds of sensors. It's often built around this concept of a digital twin.
I've heard that term, so that's a virtual replica of the physical machine. A constantly updated virtual replica. The AI isn't just checking if the temperature is a bit high. It's analyzing these incredibly complex data streams. You've got high-frequency vibration sensors, you have thermal imaging cameras, you have ongoing chemical analysis of the lubricating oils, you even have acoustic sensors.
So it's listening to the machine.
In a sense, yes. A deep learning model can be trained for acoustic anomaly detection. It can pick up the subtle, high-pitched whine of a bearing that's starting to fail, the sound of microscopic metal-on-metal friction, and distinguish it from the hundreds of other normal operational noises. A human ear could never, ever do that.
So the system flags a tiny increase in a specific vibration frequency or a change in the oil chemistry, and it knows that's a leading indicator of failure.
Exactly. The AI spots that trend 5 weeks out. That gives the manufacturer time to order the replacement part with standard low-cost shipping. And they can schedule the repair during a planned shutdown over a weekend, causing minimal disruption.
That is the very definition of efficiency.
It is. The impact is measured with a metric called overall equipment effectiveness, or OEE. By maximizing your uptime, minimizing waste, and ensuring quality, AI just sends that OEE score through the roof. And that translates directly into higher profits. You're getting the absolute maximum value out of these incredibly expensive capital assets.
That makes the financial justification for this kind of investment so much clearer. If your machines are always running at their peak, you're directly fighting back against those rising input costs by maximizing what you already have. But the operational role of AI goes beyond just keeping the machines on, right? The outline also mentioned streamlining the entire system and quality control. How does AI make the whole production process leaner?
Streamlining is all about optimizing the flow of materials and the allocation of resources. It tackles the labor and the cost issues at the same time. Let's take inventory management.
Right.
Traditional systems use these static reorder points. When stock of Part A drops to 50 units, order another 500. It's simple, but it's not very smart.
It doesn't account for volatility.
It's not at all. An AI-driven system, on the other hand, can facilitate hyper-optimized strategies like just-in-time, or JIT. It's looking at the real-time production schedule, it's looking at supplier lead times, it's even looking at projected shipping costs. And based on all that, it predicts exactly when and how much raw material to order, sometimes down to the hour. This just crushes your warehousing overhead costs. And it drastically reduces waste from inventory that spoils or just becomes obsolete. It's another direct hit against rising costs.
Right. And I'm assuming that same real-time optimization gets applied internally to the people and the machines on the floor.
100%. Resource allocation becomes dynamic, instantaneous. The system can use these really sophisticated optimization algorithms to manage the schedule. So let's say one machine is unexpectedly delayed by just 10 minutes.
A small hiccup.
A small hiccup that could cause a huge bottleneck downstream. The AI doesn't wait for a human supervisor to notice and react. It instantly reroutes the components, reallocates a worker from a less critical task, and adjusts the pace of 5 other machines to smooth out the flow. All that human effort that used to be spent just, firefighting and coordinating these complex logistics, that shrinks dramatically. It frees up your people for higher value work.
That definitely addresses the efficiency and labor side. So now let's talk quality control, especially with that market pressure for customization. More complexity usually means more chances for error.
And AI-driven precision is really the only way you can manage that risk at scale.
Mm.
Quality control used to be a person visually checking every 10th item or maybe some random sampling.
It was slow and imperfect.
Very. Today, you have AI integrated with these high-speed 360-degree computer vision systems. They monitor every single product as it moves down the line. We're talking about systems that can identify defects or deviations that are literally invisible to the human eye. Micron-level inconsistencies.
So the consistency of the output is just far beyond what a human could ever achieve.
Far beyond. But here's the really important part. The AI closes the feedback loop instantly. If the vision system detects a recurring flaw, let's say the coating on a part is a fraction of a millimeter too thin, it doesn't just flag the defective part for removal.
What does it do?
It immediately traces the problem back to its source. It pinpoints the exact machine setting that drifted, maybe a fluid flow rate, and it sends a correction command to that machine. Sometimes it can correct the issue before a dozen faulty products have even been made.
That kind of instantaneous, self-correcting feedback loop has to be vital for handling customization.
It's everything. If you're manufacturing thousands of unique personalized units, a day like custom medical implants or tailored car interiors, each one has to meet a unique set of parameters. The AI ensures that the specific production plan for that single order is met perfectly every single time. This ability to enhance quality and cut costs at the same time is the strategic bedrock of AI in manufacturing.
Okay, so if that first part was about the tangible ROI, the immediate operational wins, this next section is where we really pivot to the bigger picture, the strategic impact, the stuff that leads to growth and real innovation. And this is where it gets, for me, really interesting, because the analysis we looked at makes this very powerful distinction that says AI isn't just about automation, it's about augmentation.
And that distinction is really the intellectual core of this whole new industrial revolution concept. Automation, the way we've thought about it for a century, is about substitution.
Replacing a human task.
Exactly, replacing human muscle or repetitive manual work with a machine. The classic example is the robot on the assembly line, welding the same spot on a car door over and over and over. Past industrial revolutions were really focused on that kind of substitution.
But augmentation, as the source defines it, that's about enhancing human ability. It's about improving our decision-making. In an industry that we often associate with, physical work, how does AI actually augment a human operator on the factory floor?
It acts as a kind of sophisticated co-pilot. It's not a replacement. Think of it this way. Instead of a human operator trying to watch 10 different dashboards and manually track all these complex logistics in their head, the AI does the heavy lifting. It synthesizes all that real-time data we just talked about, the predictive maintenance forecasts, the OEE scores, the dynamic inventory levels, and it presents the human with the optimal next decision.
So the person is still in charge.
The person is still the final decision maker. They're still responsible for creative problem solving, for synthesis, for handling the unexpected, but their capacity is just amplified 1,000 times over by the AI's analytical power. So for example, when a totally new, complex fault occurs on the line, instead of an engineer having to spend a week digging through thousands of pages of log files.
A needle in a haystack.
A total needle in a haystack. The AI can instantly analyze all that data and highlight, say, the top 3 most likely root causes. It can draw connections from a global database of similar failures and its own local operational history. So the human expert can then focus their unique experience on solving the why, because the AI has already handled the massive complexity of figuring out the what.
But doesn't that create a risk? A risk of over-reliance? If the AI is doing 95% of the problem solving, what happens to the human skill base? Isn't this just, a fancier path to the same automation outcome?
That is a crucial question, and it really gets to the heart of the strategic shift that's required in training and in management. The human's role changes. It shifts from monitoring and reaction to complex supervision and strategic intervention. Augmentation means that human expertise is applied at a much higher leverage point. So if the AI is managing the day-to-day complexity of keeping production stable, the human is now freed up to focus on continuous improvement. They can design better workflows. They can troubleshoot those genuinely unique problems that the AI has never seen before. It really changes the conversation from how do we cut labor costs to how do we drive more high-value innovation.
And that focus on innovation connects directly back to that huge market pressure for customization, this idea of personalization at scale.
Yeah.
The source material claims AI gives companies the power to innovate and customize products like never before.
This is truly the strategic differentiator in the market today. We're talking about moving beyond mass production to something people are calling mass personalization.
Which means
It means being able to efficiently manufacture millions of unique items. Each one is tailored to a specific customer's order. Maybe it has unique materials or a unique geometry, but you're making it at a cost and a speed that can compete with standardized goods.
so the challenge that AI is solving there is just the sheer administrative and mechanical complexity of it all. Can you walk me through what that actually looks like on a production floor?
Yeah, think about the data required for that. It means every single unique order needs a unique bill of materials, a unique routing path through the factory, custom machine tool paths, and its own set of tailored quality checks. For, say, a medical device company, that could mean managing thousands of devices produced daily, each with its own individualized tolerances, material densities, and coating thicknesses.
A human-run system couldn't possibly handle that.
A human system using spreadsheets and traditional software, it would collapse. The error rate would be exponential. And AI can handle this seamlessly. It generates a unique, optimized production path for every single order, and it does it for thousands of them simultaneously. It's dynamically adjusting inventory, machine settings, and robotic tool paths, all within milliseconds.
The company that can deliver that level of customization, faster and cheaper than anyone else, they don't just win a little market share, they completely redefine the entire market.
They do. And to get to that level of agile, personalized production, you have to bring in data from way beyond the factory walls. This is where the crucial role of AI-driven analytics comes into play. We're not just talking about watching machine efficiency anymore. We're talking about watching the entire global ecosystem.
Okay, so what kind of information is it analyzing, and how does that feed back into production decisions?
The AI is pulling in data streams from across the whole value chain. It's looking at customer needs, of course, through sales data and even social media sentiment, but it goes so much deeper. It's pulling in market trend data, competitor product launches, changes in regional regulations, geopolitical risk assessments, forecasts for commodity pricing. It's the difference between making what you think customers want and making what you know the customer is going to want tomorrow.
And at the same time, figuring out the cheapest, most reliable way to source the materials to make it.
Exactly. This deep analysis allows for what the source calls more agile and responsive production processes. And in the economy we've seen over the last few years, agility is the only real defense against constant market shocks.
And that links all the way back to that strategic squeeze we started with.
Yeah.
That agility is what you need to react to the rising input costs or the supply chain disruptions.
Absolutely. Think about supply chain resilience. Let's say a key shipping port shuts down unexpectedly, or the price of a critical component doubles overnight because of some event. An AI-driven system can instantly identify viable substitute materials that still meet all the quality specs. It can recalculate all the production line parameters to handle the properties of the new material, and it can instantly reroute the order to an alternative supplier that its risk model has already flagged as stable.
That's dynamic strategic sourcing, but it's happening automatically.
And it shortens that feedback loop between the market and the factory floor almost to zero. It makes sure you're always making things that are in high demand and are economically viable to produce. You avoid that classic manufacturing trap of sitting on a warehouse full of expensive, obsolete inventory because you just couldn't pivot fast enough. It turns a defensive necessity into a proactive, competitive weapon.
That deep integration of operational intelligence with market foresight. It brings us perfectly to our third and final section. This is where we connect all these dots and look at the highest level. AI as a complete strategic framework. We've got to recap this profound shift. AI is not just a tool for one department anymore. It's now driving the entire business strategy.
And that is the critical synthesis here. Historically, when a new industrial technology came along, whether it was the conveyor belt or the first generation of robotics, it was implemented to optimize a business strategy that already existed. They were tools, they made the line faster, or they improved the accounting. They were supportive of the strategy.
But what the source material is implying is that AI is now defining what's even possible. It's driving the strategy itself. How does that actually play out in a boardroom?
It plays out through real-time integrated intelligence. Because the AI gives you this continuous, predictive, and comprehensive view of every single part of the business, from a microsensor on one bearing all the way up to global market sentiment, it forces strategic leaders to make decisions with an unprecedented level of foresight. So strategic planning, it stops being this thing you do once a quarter based on data that's already old. It becomes a process of continuous, data-driven optimization. If the AI detects a persistent failure pattern in a certain product line that can't be fixed with simple maintenance, it might recommend a complete redesign. Or it might suggest pivoting investment to a new microfactory in a region with a more stable supply chain. The technology isn't just executing the plan, it's informing and iterating on the plan in real time.
And that ultimate strategic goal that you mentioned, doing more with less, that really encapsulates this entire victory, doesn't it?
It does. It's the perfect counterattack to those twin challenges. It's how you fight back against rising costs and labor shortages. You grow through efficiency and innovation, not just by trying to cut costs.
If we connect that kind of profound shift to the bigger picture, it explains why the source analysis concludes that we're on the cusp of a new industrial revolution. I mean, that's a huge historical claim. What is it that makes this one so different from the ones that came before?
That really is the pivotal question. The first industrial revolution, that was steam and mechanization. It gave us the ability to apply massive power. The second was electricity and the assembly line distributing power and standardizing output. The third was computing and digitization, the ability to process information.
And this one.
This fourth industrial revolution, driven by AI, is fundamentally a revolution of intelligence, of foresight. The technology is providing a predictive capacity and a systemic agility that simply did not exist before. In the old revolutions, technology it was a powerful hammer that you used to execute a strategy that a human came up with. In this new era, AI is becoming the brain of the organization. It's defining how the strategy gets formulated, where the company should invest, and what markets are even viable, all based on this dynamic, intelligent modeling.
So if your competitor is making their strategic decisions based on an AI forecast that integrates supply chain risk and local energy price volatility, and you're still working off last quarter's reports,
You're at an insurmountable disadvantage. It's not even a fair fight. With the previous revolutions, the strategy often had to sort of catch up to what the technology could do. This time, the technology is setting the pace. It's dictating the strategy. It's a total inversion of the relationship.
which leads right into that final strategic outcome we identify in the analysis. AI helps businesses navigate and thrive amidst complex challenges. It really does seem to offer a holistic solution to all those problems we started with.
It absolutely does. Let's just quickly run through them again. Those initial complexities, rising costs, labor shortages, and customization demands. AI offers an integrated solution set for all three. It delivers resilience.
Okay, lay it out for me.
First, costs. The efficiency you get from predictive maintenance and streamlined operations minimizes waste, it maximizes the value of your assets, your OEE, and that directly counters the rising cost challenge.
Right. Second, labor.
Labor shortages. That's solved by a mix of automation and augmentation. You fill the critical skill gaps, and you free up your human workers to focus on high-value synthesis and supervision.
And third, the customization demand.
Solved by personalization at scale, which is driven by those deep, real-time analytics. It turns what was once your biggest headache complexity into your core competitive strength.
So what you end up with is a company that isn't just surviving the constant shocks of the market, it's actually using its intelligence-driven agility to outperform competitors who are still stuck in that older, reactive mindset.
It's like trying to navigate a city using real-time GPS that sees traffic, weather, and road closures versus using a paper map that was printed last year. The AI always knows the optimal path, even if that path has to change every 5 minutes.
That's a perfect analogy.
So to really synthesize the key takeaways here for you, our listener, we've basically covered 4 critical shifts that define AI as this new strategic engine. First, there's the predictive precision. That eliminates costly downtime and just maximizes the value of every asset you own. Second, there's the radical cost reduction that comes from streamlining these incredibly complex operations. Third, it enables personalization at a scale that was just science fiction a decade ago, solving that huge consumer demand for unique products. And finally, and I think this is the most important point, it has evolved. It's no longer just an operational tool, it's become the core strategic driver that dictates how business is done. And in doing so, it's really ushering in this next industrial revolution.
And as we close out this deep dive, we want to leave you with one final thought to mull over, something that sort of extends the implications of everything we've talked about. The source material shows pretty clearly that the manufacturing industry is successfully using AI to navigate labor shortages and rising costs, primarily by enabling companies to, as we said, do more with less. So if this technology is effectively solving the immediate problem of not having enough skilled workers by accelerating capacity, we have to ask, what does that mean for the future of the global supply chain long term? Are we moving toward a future of hyper-localized, highly personalized manufacturing hubs? If your reliance on a large, centralized human workforce goes down, does the strategic focus shift away from chasing the cheapest labor around the globe and instead shift toward maximizing resilience and getting physically closer to your customer?
A really interesting question.
And maybe more profoundly, if the human role truly shifts entirely to one of augmented supervision and continuous innovation, what are the next strategic challenges that this revolution is going to create? Long after the problems of cost and labor have been solved by the AI, will the new competitive advantage be defined not by your physical factory, but by the quality and the intelligence of your AI model itself?
The revolution isn't just about making things faster, it's about thinking faster. And the questions are really just beginning to unfold.
Stay curious, keep thinking strategically, and we will catch you next time for the deep dive.